Hello everyone, I am Krishna Sasank. I am a peer mentor of Artificial Intelligence. In this semester, I am peer mentoring for deep learning. Today I am discussing about bias variance and trade-off topic of deep learning. In this PPT, we have these contents. We will see further what we have. Introduction for this topic. Deep learning is a branch of artificial intelligence that enables machines to analyze data and make predictions. However, if deep learning model is inaccurate, it can introduce prediction errors, and these prediction errors are commonly referred to as bias and variance. These errors are always present in machine learning or deep learning because there is always a small difference between the model prediction and actual prediction. The major goal of ML data science analyst is reduce the errors and get more accuracy result. This topic discusses the bias and variation trade-offs, underfitting and overfitting. For decreasing for getting more accurate results, we use bias and variance, and decreasing inaccurate results. We can see errors in machine learning. We can describe an error as an action which is an inaccurate or wrong. In machine learning, error is used to see how accurately our model can predict on data it uses to learn, as well as new unseen data. Based on our error, we choose the machine learning model which performs based for particular data set. In errors, there are two types of errors in machine learning model or deep learning model. There are reducible errors or irreducible errors. There are two types. Reducible errors are those errors whose values can be further reduced to improve a model. They can be caused to because our model output function does not match the desired output function can be optimized. What is it can for using the reducible errors we can further reduce the errors in the model, and we can get accurate results. For irreducible errors, we always present in a machine learning model because of unknown variables, which values cannot be reduced. Where for some models we have unknown values, unknown data in that data set, which we cannot remove. So that is called irreducible errors. We can further divide reducible errors into two types. There are bias and variance. Well, firstly, we can see here diagram. Machine learning errors are two types: reducible error and irreducible errors. In reducible, there are two types: bias and variance. Now we see bias. What is bias? Bias means when we have model, when we making a predictions, we make predictions, right? There is a difference between the model predicted value and actual expected value. This is called bias, where models predict some value for the output, and but the actual value it will be different. So it is called bias that predicts the output. That is called bias. In bias, there are two types: low bias and high bias. A low bias model will make fewer assumptions about the form of target functions. Low bias means we have some certain targets which it gets all the targets is called low bias. Examples of low bias are decision tree, KNN neighbor, and SVM, support vector missions. And high bias is a model with high bias make more assumptions, that is a high errors, and model became unable to capture the important features of data set. Is called high bias. When high bias means when we get high errors for a training data set is we call high bias. High bias model cannot perform well on new data, for a new data or a extra data. For examples of high bias are linear regression and linear discrete analysis and like logistic regression. Like low bias means we have some model uh, when we have training data which it satisfies all the points is then we get small low errors, so it is called low bias. When you are getting high errors which is that does not satisfies the points of our data, so we will call as high bias. This is bias topic. Measures to reduce high bias, where measures to reduce high errors in a model. High bias mainly occurs due to much simple model. Below are some ways to reduce the high bias. For decreasing high bias, we can do these things for decreasing high bias in model. First, we can increase the input features as model is underfitted. We can see underfitted in the next slide. For decreasing, we can put more inputs for decreasing the high bias, and decrease the regulation term and decrease the regulation term. Use more complex models such as including some polynomial features, not only binary features. We can also polynomial features also we can use. in a model. And this is bias and how to reduce the high bias. Variance. Next topic is variance in a reducible errors. Variance indicates how much random variables differs from its expected values. Like in a model, it expects some value for the output, but it indicates that how much random value differs from the expected value. That is called variance. We have variance have two types: low variance and high variance. Low variance is a small variation in objective function predicts with the changes in the training set. Low variation means when you in a model we are giving training data set. Now we are giving a new data set for a model after getting training data set, and when you get a low errors, it is called low variance. When you get a high errors, it is called high variance. This is a simple point. Some examples of low variance are linear regression, logistic regressions, and linear discrete analysis. High variance indicates large variation in objective function. As we can see, if we get more errors in new training data set, new data we are giving to the model for training. So when you get a high error, then it is called high variance. So it is called high errors. Some examples of decision tree, SVM, KNN are the examples of the high variance. A model that shows high variance learns a lot and perform well with the training data set and does not generalize well with the unseen data. Like we can say, if you are giving a new data set to the model, if we if we getting high variance, that means it is getting more errors as a for the training data set. As a result, such model gives good results with the training data set, but shows high error rates on the test data set. We can see high variance means we getting good model but giving errors on the testing data. Since with high variance the model learns too much from the dataset, it leads to overfitting of the model. A model with the high variance has the below problems. When we have high variance for the model, we have these two problems. A high variance model leads to overfitting. Like overfitting means low bias and high variance. Like when low errors on testing training data set, and high variance means high errors on new giving data sets. These are the high variance of problems and increase model complexities. And this is one of the point for the problem. Methods to reduce high variance. If the model is overfitting, reduce the input features or parameters. Like if overfitting means we know low bias and high variance. For overgetting that, reduce the input features or parameters. For reduce the inputs for giving that model or parameters. Like more inputs not giving. So don't use very complicated models. Use a simple model and increase the training data rather than testing data. Like new data. Increase your training data that you can decrease the high variance. Like these are the bias and variance. As we are seeing above in bias and variance, underfitting and overfitting. Now we can know very well in here. Underfitting means when a model does not learn patterns well enough in training data to generalize well to a new data set, then it is called underfitting. Like we can see now. Wait. Like we are seeing here underfitting diagram. This is a trading model. These are the testing data. These are not satisfying the training data. First, we will give to the model. This is one model. This is the training data. We have to satisfy this line, but the training data does not satisfying this line. So we are getting high error. We call high bias now. This is the we are giving the testing data, new testing data. So we are for testing data also is not does not satisfying the input. So we are getting high variance here. Like see overfitting in this point, some are satisfying points, that is low bias, some low errors for a training data. For a new testing data, some more are not satisfying, so we can have high variance. So overfitting has low bias and high variance. So the underfitting means high bias and high variance. That is high error when in testing data and training data also. In overfitting, we will get a low bias in training data and high variance in testing data. That means high error in testing data. We have another model, balanced model. In this model, where testing data and training data satisfies the mostly satisfies the input. Mm, Here we can see some are satisfying, almost are all satisfying here. This is training data set, this is a testing data set, new testing data set. These are satisfying this line, and we can call it as balanced rate model. Like low bias and low variance, low error for training data set and low error for testing data set also. Like these are the underfitting and overfitting and balanced model. Like we can see here, as I said, overfitting is when a model performs very well on training data but poorly on testing new data. This is known as overfitting. Like overfitting means it performs well on training data, but it gives low error on training data, but it gives more error on new testing data. When you give a new data, it gives error. So this is known as overfitting. So we have this for overfitting, low bias and high variance. When underfitting, it it uh, it generalized well data to new data. It does not call it generalized to new data, but it gives the high error to the training data. It gives low error to new data set, like that. This is called underfitting. Balanced bit. When a balanced model is one that performs well on both training and test data. This may not be accurate as an overfitting model and range, but balanced model will perform on testing. Balancing model, we can see it performs well on testing and training data sets. So it have low bias and low variance. So these are underfitting and overfitting. So we have some combinations of bias and for bias and variance. So there are four possible combinations of bias and variance, which are represented in the below diagram. Like we can see, these are first low variance and low bias. Like when your model, when the model is satisfying the both training data set and giving new data, so then we have low error and low error for training, so we can call it low bias, and we have low error in testing data, so we have low variance. So we have one case is low variance and low bias, and another case is low variance and high bias. That is when a training data does not satisfy the model mostly, we get more error. So this is called high bias. When the given new input error it satisfies the model, so we can see some points getting near the model. So we have some normal errors on testing data. So we call as lower variance and high bias. Next one is high variance and low bias. Like we can see for training data, there are some errors. So there are only some small errors only. Mostly of them satisfying. So we call it low bias. For testing data, it does not satisfying. There are more far than a model. So it is called high variance. Like that same high variance and high bias also. It does not satisfy training data and testing data also. So we can see as mostly one or two will satisfy the testing and training data points. So these are the combinations of bias and variances. As I explained before, these are first two, we have four combinations, low bias and low variance. So the combination of low bias and low variance shows an ideal machine learning model. However, it does not possible practically. So we have models. So in a model, it does not possible with low errors for bias and low error for testing data and low error for training data. It does not possible practically. So it does not have low bias and low variance. Next one is low bias and high variance. With low bias and high variance, model predictions are inconsistent and accurate on average. This case occurs when a model learns with a large number of parameters and hence to the overfitting. That overfitting means we know low errors on training dataset and high errors on testing dataset. Next one is high bias and low variance. High bias means high errors on training dataset and low variance means low small errors in testing dataset. With high bias and low variance, predictions are consistent but inaccurate on average. This case occurs when a model does not learn well the training data set or uses fewer number of parameters. It leads to the underfitting problems in the model. And fourth one is high bias and high variance. With high bias and high variance, predictions are inconsistent and also inaccurate on the average. So these are the four possible cases of the combinations of bias and variance. So how to identify high variance or high bias? As we can see, these are the error and training decisions. When we are getting testing error has more on a training data set, then we call as a high bias. When you're getting a more error on testing data, we call as a high variance. So high variance can be identified if the model has low training error and high testing error. High bias can be identified if the model has high training error and a test error is almost similar to the training period. We can see here that was. So next one is bias variation trade-off. When building a machine learning models or deep learning models or any model, it is very important to pay attention to bias and variance and avoid overfitting and underfitting of the model. If the, if the model is very simple with a few parameters, it may have low variance and high bias. That means low error on testing data and high error on training data. On the other hand, if the model has large number of parameters, the variance will be high and the bias will be low. Like if the parameters high, the variance error will be high. That is the testing data error will be high and the training data error will be low. Therefore, we need to balance bias and variance error. This is called a balance between bias and variance error. This is called a bias variance and trade-off. As we can see, this is error model complexity. This is bias graph and this is variance graph. If bias is decreasing, the variance will increase like this. So at some point it will collide with this. So we can have some good model when it is collide. So this is a topic of bias variance and a trade-off. And thank you.